Our keynote address will be given by Dr. John Ratey, who will present on keeping your brain young. Dr. John J. Ratey is an associate clinical professor of psychiatry at Harvard Medical School and an internationally recognized expert in neuropsychiatry. He has published over 60 peer-reviewed articles and 11 books published in 15 languages, with a 12th book on its way. Dr. Ratey has established himself as one of the world's foremost authorities on the brain-fitness connection. John attended Colgate University, where he was a Washburn Scholar, receiving his bachelor's in philosophy before moving to Boston. Finding work at Harvard's Massachusetts Mental Health Center as an attendant, John was often assigned with caring for some of the most difficult patients, inspiring him to learn more about how to help those with mental health challenges. Seeing a career in psychiatry as the path, he completed his science requirements at Harvard before returning to Pennsylvania to attend the University of Pittsburgh Medical School, where he won multiple awards for scholastic achievement in psychiatry. Returning to Harvard for his psychiatric training, John was eventually named inpatient chief resident. Upon graduation, he was awarded the Elvin Semrad Teaching Fellowship at Harvard Medical School and was appointed Harvard's Assistant Director of Residency and Medical Student Training, a position he held for 9 years. It was during these early years at Harvard Medical School that he began his groundbreaking research on aggression, autism, and ADD, leading to a career of speaking and teaching around the world. Recognized by his peers as one of the best doctors in America since 1997, he was recently named Outstanding Psychiatrist of 2016 by the Massachusetts Psychiatric Society. Dr. Ratey maintains a private practice in both Cambridge, Massachusetts, and Los Angeles, California. Please join me in welcoming Dr. John Ratey.
Thank you. Thank you all for staying. I'm a little jet-lagged. I just came back from China. I was there until Saturday or Sunday night. I can't remember which, but I'm getting over that now. But anyway, to begin with, I want you to all stand up, stand up, stand up. We can't get, you're not going to get away without doing a little bit of exercise here. Okay, I want you to put your hands out in front of you like this, just like that, and then pull them back really hard. And then if you can, bend down and touch the floor. If not, you can sit back on the chair. We'll do that about 7 times. Pull back hard and back down, touch the floor. That's right, and pull back hard and down, touch the floor. Is that 7? No, it's not. Boom, touch the floor. Come on, a couple more times. That's it. A couple more times. One more. Boom. Okay, good. Now, what you've done is you've turned your brain on a little bit, and especially your attention system. It's one of the things that I've made a lifetime in studying. And one of the things that our orchestra, a 91-year-old fiddle player, violinist said, is that playing music keeps your brain young. Learning how to play music will keep your brain young. Taking any challenge keeps your brain young. That's the point. That's the way to keep our brains young, and we know so much more about that these days than when I started. So there was this big study that was done at the end of the 80s in multiple countries about looking at 20,000 people and looking at what prevented them from having the onset of cognitive decline in Alzheimer's disease. This was a MacArthur study. It was a really well-done study, a bunch of neuroscience people. And so they came away with 3 factors that prevented cognitive decline in Alzheimer's disease, because we were beginning to see that the population of the world was aging, and we had to do something about it. So this was their first step. So they found 3 factors, and they were, the first was ideal weight. The second was continuous learning. And the third was exercise, physical, active exercise. We knew about the first 2. We had studies on that, and we knew about that. But exercise was something that no one even thought about much, other than it lowered weight, it helped our blood pressure, helped our cardiovascular system. All that was known. But it was the most robust factor in this study. In other words, it was the most important factor. So one of the scientists, a neuroscientist named Carl Kottman from the University of California, Irvine, went back to his lab and he said, I'm going to find out why this is so important, why exercise does it. So he got a bunch of mice, because that's what neuroscientists love to do. They like to get mice and study them, right, and see what happens. So he got a bunch of mice, and he tested them first. I say he gave them the mice SATs. Some audiences don't know what the SATs are, or the ACTs, or anyway, he gave them a bunch of cognitive exams. And then he taught half of them to run in these running wheels. Put them in their cage and showed them how to do it, and they took to it, those that had it. So he found that they were running about 4 kilometers a night, which is a long way for a little mouse with really little legs. So they liked it. They liked to run. And then they had another group, their brothers and sisters genetically, who weren't running, tested them too. But then at the end of 7 days, at 10 days, at 20 days, he retested them. Their scores went up about 75%. Their test scores went up. Can you imagine that happening with your SATs? Anyway, but he also looked at their brains, which is why we do mice first, right? And he looked and saw that when he looked into their skulls, saw that the top part of their brain was much thicker. It had grown. It was much more connected. Then he weighed their brains and compared them to the control group and found that they weighed more. And then there was an area of the brain called the hippocampus, which is all about memory and learning, and now we know it's about stress regulation and anxiety and all that. Very important area of the brain. That was bigger in these running mice than their brothers and sisters who didn't run. So just by having 7 to 10 days of running, these mice were smarter, their brains were bigger, and they had more of this stuff called BDNF, or brain-derived neurotropic factor. And if there's one thing the students should go away with is remembering this growth factor, because this is the growth factor, the mother of all growth factors for the brain. It's brain-derived neurotropic factor, meaning it helps our brain cells grow. And it did this with our mice. So they measured it before and after. It went up 200 to 300% in 7 to 10 days just by running. So this just was incredible. He had to do it again and again and again to prove it to himself and to his lab assistants that this really happened. And then he started presenting it around at meetings, and he was ridiculed, and oh, this is just BS. But it started this revolution. My book is called Spark, the Revolutionary New Science of Exercise in the Brain. And from this point on, neuroscience took a jump forward. And it was all about how to keep our brains young, keep our brains from eroding, and all about this substance, BDNF, because it truly was fertilizer for the brain. It keeps our brain cells young and perky and helps them do what they're really supposed to do. We have 100 billion of them, and their job is to grow. Their job is to grow and connect. And aging, when we age, we begin to have them not grow so much and not connect enough. And so we begin to see erosion. And so this led to all these studies that just keep coming and coming and coming out there, looking at this BDNF material. All the drug companies were trying to make it, trying to make drugs that made more of it because it became the real thing in terms of not just aging, but making us smarter, making us less depressed, making us less anxious. All this was part of the deal, part of what this BDNF did. Well, anyway, we went on and on doing all this research, and what we saw from this point on, this one study really published in Nature, and it just hit the world on fire. And so then we had neuroscience departments around the world really looking at exercise and its effect on the brain, physical exercise and its effect on the brain. How could this possibly be? Well, we know a lot about it. And this is a look at the number of articles, scientific articles, that have come out since this study really hit the press. So you see this hockey stick kind of graph, which shows it in tremendous number of new studies all the time. I get sent every Saturday morning at least 100 new abstracts from the National Library of Medicine that have been published that week on exercise and its effect on the brain. Uh-oh. Speaking of which, what have I done? But nevertheless, what we've learned is that our brains grow, and that this is their job, is to grow and prosper. And the more they grow, the better we are. The more connected we are, the more we learn. We know that the secret of learning is what happens in the brain is that our brain cells have to grow in the information. We have to transform our brain cells to hold that information. And what we've learned along with all this is that exercise creates the perfect environment for our brain cells to grow in. We also learned in 2000, a couple three Nobel Prizes were given to show that we were growing new brain cells, that we actually grew new brain cells every day. All of you grow new brain cells. And the people playing music grow a little more than you just sitting there listening to music. And exercise helps us make the most. And this was a big deal because we make new brain cells from these stem cells we have in our brain. And so this is the reason why their little mice brains were bigger, because they grew more brain cells, especially in this area that's the sort of cross center for memory and learning, or the hippocampus. And so it seemed as though when we were moving, we needed more brain cells to help us learn new information. Well, the good news is that it never stops. We never, even when we're 91, as our conductor here was, we're still growing new brain cells. This is a recent study that came out in last year showing this, that it doesn't matter what your age is, if you are using your brain, you are going to produce more new brain cells. And this is part of the magic of keeping our brains young and perky and ready for action. Now, I got really excited about all this and went and wrote a book called Spark, and went back and looked at our forefathers and foremothers and said, why is exercise, why is moving so important? Well, went back and looked at our hunter-gatherer past. We're still a bunch of hunter-gatherers. We still have the genes that our hunter-gatherers sort of evolved over 6 to 8 million years when they were moving and across the savanna and the jungles and And this is when our brains grew big. Our brains grew big during this period of time because we were moving so much. We were moving and we learned how to do things better. So our big brains were created during this time, or we added to the brains we had, this area of the brain right at the front from the red splotch, which is called the motor cortex, and in front of it is the frontal cortex. All that added on during the time that we were hunter-gatherers, that we were adapting to new environments all the time. We added those brain cells on, and eventually those brain cells, and not just helping us move and adapt and to predict and to move better, be more precise, and all the things that we did as we evolved, but we used those same nerve cells to think with. And one of our great neuroscientists said, that which we call thinking is really the evolutionary internalization of movement. And that's really what the center of the reason why moving keeps our brain young. Because when we move, our brain cells are working. And when they're working, that helps us to think better, helps us to do better on tests, but also keeps our brain cells alive. Now this, of course, is what we think about moving today. You know, we make it easy. This is an actual 24-hour fitness center in San Diego, California. So we think this, you know, we want to make it easy for ourselves, and it's a wrong way about it, but because movement is so much out of our life that we need to put it back in there, to stand more, to move around more, to walk more. So you have all these neuroscientists now who are leaders in the field of Alzheimer's research, preserving our brain, changing from chasing medicines to say, let's really live better. Let's live differently, because that is the way to go. By changing the way we live, by living as we used to live, where we moved a lot, where we ate differently, where we slept enough, where we were mindful of where we were and who we were and who we were with, and we were more connected. You know, the great thing about the orchestra before is they come together and they're all connected. They're in what I call a small tribe. They've formed us another tribe to be connected. Well, that's magic in terms of keeping your brain young and perky. And then they're moving along with that. So we've had many, many studies showing that exercise is really good to reduce the potential for us to lose our brain function and to develop Alzheimer's disease. It's said that if you begin to exercise in your middle life, whatever that is these days, and you stay with it, you will push back cognitive decline, or losing your mental functions, by anywhere from 10 to 15 years. And you can cut, if you do that, you can cut the risk of developing Alzheimer's disease in half. So it's something that everyone should be aware of, know, and shout to the world. Some years ago, the Department of Neurology at the Mayo Clinics went and reviewed 1,600 scientific papers that had come out in the previous 10 years, looking at exercise and its effect on the brain. Their unanimous conclusion was that it was definitely the thing to do to keep your brains young, to keep your brains working for you, to make your brains work better, and to keep your life working well. along with the fact that we think what we know, that exercise helps your heart rate, helps your blood pressure, helps your sugar, helps your muscles strength, helps all the physical stuff. Their focus was on the brain, and my focus and mission in life has been to go and talk about the brain and what exercise can do. Now, this is one study that really says it all. This was done in Illinois, where they took 100 people who were 69 average age. They were not exercisers. They began to have half of them come in 3 days a week and get on a treadmill for 40 minutes, for eventually getting their heart rates up to where they were sweating for 6 months. They had another 50 who came in just to stretch, and then they compared them after the 6 months period of time. What they saw was, like the mice, the running mice, those 69-year-olds who were moving for 6 months, who were moving, did a little better on their test scores compared to the people coming in who just stretched. But what they did is they looked at their brain scans before and after. So this is a composite of all those brain scans that they had before and after. What you see here in yellow and in blue are the result of what happened after 6 months. Those areas are areas of actual brain growth. Their brains grew when they were 69 years of age in those areas. And those areas are involved in thinking and in memory. So there's a lot we know. As I say, there's evidence coming out all the time. And this study sort of, again, bringing it more recently. But we know, too, that you can start to exercise later in life. I took down a picture on your left because it wasn't modest enough. It's of a 74-year-old woman who was posing in a muscle building competition when she was 74. When she was 56, she was obese, and she had been obese all of her life. And she decided she was going to make a difference. So she started running, then going to the gym, and then she was winning all these awards, and then in her 70s continued to do that. She's 79 now, and she has all these groups in Baltimore helping the elderly get fit and stay fit. Even more of an example is the fellow right there, Mr. Singh, who at the age of 80 had never exercised. His wife died. Next year, his son died. He became depressed. He went to the doctor, and the doctor said, "Start running." So he did, and then he continued to run. There he is at the age of 100, finishing the Toronto Marathon. He retired at the age of 101, finishing the Hong Kong Marathon, and it was carried on ESPN, believe it or not. The point is, it's never too late. You just have to begin. It's one foot in front of the other, or taking a yoga class, or doing something fun like Zumba, or anything to get you moving and that you'll come back to. That's what's important. What we've known, and we've known for a long time, looking at groups that have been very successful in aging. This is a group in Mankato, Minnesota, up in Minnesota where you were. They're famous because they're long livers. It's a group of nuns. I always forget what, I was taught by nuns, and I always forget what branch of nuns they are, but they tend to live to be 100 plus in their retirement home. And there's a bunch of them, and they're all involved in running the place. and moving a lot and playing Jeopardy and playing bridge and crossword puzzles and then they started being studied by the University of Kentucky, and they looked at their brains and began to measure their cognitive test scores every year. And one of the nuns, Sister Bernadette, showed no sign of aging. Her cognition, her thinking and memory were absolutely crystal clear. She was sort of one of the head nuns. Well, anyway, she died of a heart attack. They looked at her brain, and her brain had stage 6 Alzheimer's disease, but no symptoms of having Alzheimer's disease, even though she had carried both genes that can code to make you more likely to have Alzheimer's disease. Now, it's said that these nuns live such a long life because there's no men around, you know. But I'm not sure that that's the right answer. Now, one of the things we know about successful aging is keeping your balance together, working on your balance and coordination as we age. All of us lose it. We lose balance. And we lose balance is a threat for us to fall. And if we fall, we break bones, especially our hips, and then that leads to further decline in our movement and in our activity, and that's a huge problem. So we have to always pay attention to working on our balance and coordination. Then we have this problem, which we're all sitting far too much. If you read the papers over the past 6-7 years, you're seeing a study come out here, there, and everywhere saying we have to get up, we have to move, we'll live longer, we'll prevent the onset of Alzheimer's disease if we stop sitting so much. So and a big part of sitting goes along with aging, because we get tired and we don't want to get involved, and so what happens? We start to gain weight. Remember, in that study that showed, from the initial study, it was ideal weight was important, maintaining your weight. But when you start to gain weight, it codes for more rapid onset of Alzheimer's disease, partly because when we evolved, we also carried with us what we call our thrifty genes. People want to know, why do we, in the past 50 years, have such an obesity crisis throughout the world? Well, a big part of that is that we're not moving in our jobs, we're not moving in our lives, and we are eating the wrong kind of food. But our genes are part of the problem. They drive us to eat the highest caloric food that we can find and to store it. Think back, if we were hunter-gatherers, that was our mission, to find the highest caloric food that we could find and eat it and store it and only use it when we needed to, because tomorrow we might starve and we might have to move 10 to 14 to 16 miles the next day. So this is a natural kind of problem, but it leads to real trouble, and especially with our change in a diet. This is a doctor talking to one of his patients, aging patients. He says, that high-carb diet I put you on 20 years ago gave you diabetes, high blood pressure, and heart disease. And the doc says, oops. But it also led to her early cognitive decline and Alzheimer's disease, because when you begin to have trouble managing your sugar, your glucose, you're not only going to put the weight on, but you're going to push yourself towards diabetes type 2, which is a real code for early Alzheimer's and loss of brain function. And it's a real problem, such that there are some Alzheimer research centers that call Alzheimer's diabetes type 3, because it's so prevalent among people who have diabetes type 2. It's such a lead-in, and we now, most physicians now are talking about how sugar is such an evil thing. Sugar is a risk factor. High glucose is a risk factor for toxicity in your brain. It helps bring on the degeneration and the erosion of our brain cells. It creates too much of a toxic environment. And many of our researchers have turned to paying attention to this, to getting people healthier and saying, look, if you want to live successfully into the older age, you really have to pay attention to the things that your mother and your grandmother told you. Eat regularly, sleep regularly, exercise and play as much as you can, be involved with people, and pay attention to who you're with and what you're doing. Those are the keys, so that this book came out now 2 years ago, called The End of Alzheimer's Disease, by Dale Bredesen, a neurologist who had been studying Alzheimer's disease all of his life, and finally realized that it was really getting people onto the right living course, not the right drug, which he had been researching for many decades, and has this wonderful protocol for how to keep your brains young and healthy. But a big part of it is exercise, is moving, is getting a Fitbit and going 10,000 steps to begin with, and doing something you enjoy so you'll come back to it. And one of the big things in aging is boosting your attention, keeping your attention going, because as we age, we tend to lose our attention. Just like in a large part of my life, I've studied and wrote about attention deficit disorder, but they're very similar, that you begin to forget things and mishear things and all of that. And so when I wrote this book, Spark, I was very interested in most of the chapters are about aging and making our brains work better for us. But there's also a chapter on attention deficit disorder. Now, when I started the book, I inherited this little dog, a Jack Russell. Does anybody have a Jack Russell in the crowd? One, okay. God bless you. The breed has attention deficit disorder. When I got this Jack Russell, I took him to the vet and I said, what should I do with him? He said, put him on medicine now. Instead of that, I developed an exercise program for him to help him deal with his attention problem, which were many, very many. It was incorrigible, always a nudge, loved. For some reason, the breed also loves to eat Oriental rugs. So that was a big problem. So what I decided to do is I took my little dog out to the backyard every morning, and we had this game. I had a hill in the backyard, and I took out 3 tennis balls, and I threw one to the top of the hill, and he ran up and got it and came down very proud, not going to drop it because they're bred not to drop things. But then I had 2 other tennis balls. So I threw the other one to the top of the hill. He ran after that, came back down, and then our game began. So for the next 15 minutes or so, he was running up and down the hill. Now, I had a problem in that I didn't know what to call him. There was a lot of good names out there. So I went for my usual 3-mile run in the morning, where when we move, we know we have great ideas, heuristic ideas, more creative, and we have studies showing that in fact that's true. We're more creative, usually when we're walking and not running, but I went for a run and I came back with his name, and I called him Jack. So the creativity really worked. Anyway, after I have his morning run, he could come in and do his homework, because they're very smart animals as well. And I had him do his reading and writing and take notes for me. So I called it the Jack effect that exercise is, and we have written 4 books on attention deficit disorder, always talking about the benefits of exercise for attention in general, whatever the issue is, whether it's aging, whether it's a real attention deficit disorder, whatever, it's a problem, and exercise helps to fix it. But there are some days when I can't get him outside for recess, and he gives it to me. Oh boy. He gives it right back to me, saying, look, you didn't take me out, I'm going to turn to my old ADD ways. So what happens? When we exercise, what happens? Our brains get turned on, especially the front part of our brain. It turns on the area of our part of our brain that does the planning, the organizing, the predicting, the evaluating, the maintaining our focus, and it holds our working memory. These are areas that are key and crucial in all of us, but especially as we age. And we have such data showing that when we exercise, we make this area bigger, better, and along with the memory center of the brain, the hippocampus, they work better together. We have a better memory, we have better recall, we think better when we exercise. Now this sort of points it up. This is looking at 20 kids who were 10 years of age. They came into a classroom, sat down, and had their EEGs measured. It measured their electrical activity in their brain. Then they went for a 15 to 20-minute walk, came back, had their EEGs measured again. And these are the summaries of before and after. What happened? They got more colors. More colors indicate more activity, more brain activity. Just by moving for 15 to 20 minutes, their brains were more ready to be engaged, to be used. And this is what we see as we age as well. Also, one of the things, being a psychiatrist, that I'm interested in and have been, is how to help people who are depressed. Well, you go back to 300 BC to Hippocrates, who wrote the first textbook in medicine. And what did he say? Very wise man. He said, if somebody comes into my office and they're depressed, I tell them to go for a long walk. If they come back and they're still depressed, I say, keep walking. Keep walking, because this was the cure. Well, we know this is true, because now we have evidence at Duke University Medical School, who really started this off back in the 80s, looking at exercise as a way to treat cardiac problems or heart problems. The psychology department was noticing, wow, these people who are getting treated for their heart problem, their psychology is so much better. They're less aggressive, they're less depressed, they're less anxious. So they began to report on this and then studied it. So they looked at this in a large study at Duke over a 4-year period of time, where they had 100 people come in over that period of time who were mildly to moderately depressed. gave a third of them, and not all of them had not exercised, never did. A third they began to exercise. A third they put on increasing doses of antidepressants, and a third they did both, the antidepressant and the exercise. And what they found after 4 weeks, that they all became undepressed and stayed that way for the 4 month of the study. Well, this got criticized and criticized because there's no placebo group, and in medicine and science you need a placebo group. So a decade later they did a placebo group and came up with the same finding, that exercise was as good as our antidepressants to treat mild to moderate depression. It took the American Psychiatric Association a good 2,000 years and some to agree to this. And finally, about 5 years ago, it's listed as a possible treatment for depression. So anyway, also we know that it works for anxiety. So what does this do? What does exercise do? Exercise causes more of our brain cells to be active than in any other human activity. When we move, you're using more of your brain cells than in anything else that you do during the day, than thinking, than doodling, than playing the crosswords, and doing all that. You're using more cells. And when you use more cells, you create more neurotransmitters and more of this BDNF stuff and all kinds of other things that we're learning about that come up from the body that help our brain function at its highest. So what we know is that when we have our brain cells work, they release these neurotransmitters, these little chemicals that make our communicate from one cell to the next in the brain. And so, and this is what we do in psychiatry and psychopharmacology. We get drugs that do this, that cause a change in our brain chemistry. And that's what we want. Well, exercise does it really, really well. And is one way to lessen the burden of poor mood or of anxiety. Often then it enlightens and it motivates then all of us as we age. Oh no. Also, there's now a big focus for the past 10 years on using exercise to treat Parkinson's disease, a problem in aging. Because Parkinson's disease is because we don't have enough dopamine. As we age, the dopamine system sort of begins to erode. So exercise promotes the dopamine system to work harder, to challenges the dopamine system, which helps restore function. And we see lots of reports out there, not only about one or another person getting better, but whole communities that have Parkinson's disease, that are doing things like going to boot camp for Parkinson's patients. Boot camp. They go to boot camp to learn how to exercise and to do what kind of exercise to make their brains work better, to make their Parkinson's symptoms decrease. It also helps if they're taking medicines for their Parkinson's disease, it makes the medicine work better. What kind of exercise and how much? Well, it's not this kind. You can walk your dog, but you better get out and walk the dog. Let me see. Oh, I'm running out of time. So one of the things we know is that when we are moving, we in fact are more creative. This study done at Stanford showed 150 students that when in a bunch of different testing groups, that when they were walking, they were the highest in terms of their creativity scores. They were the best at being creative when they were walking. So that's why I came up with Jack. You know, I was most creative when I was doing my running. Well, I'll close with this finally, because I think one of the things that we're unpacking is the benefits of all kinds of good living and what it means to us. There's a group, another group I'm working with out of Stanford, looked at a big data analysis of people on Medicare B. And they did the same thing as the people in the 80s did. And look what prevented, not what prevented the onset of cognitive decline in Alzheimer's disease, but what kept people from using Medicare B. What kept people out of the hospital or out of their doctor's office? What were the factors? And they gave them positive scores. So if they took their medicine as their doctor prescribed, they got a positive score of 0.12. If they lost weight for any reason, they got a positive score of 0.2. If they began to exercise and stayed with it, they get a positive score of 0.22, better than taking the medicine as doctor prescribed. If they had been a smoker and they quit, they got a positive score of 0.52. But the big news is if they got more social and stayed more social, if they formed bigger, not bigger, but better tribes that they paid attention to, they stayed more social, they got a positive score of 0.65. So again, confirming sort of the trend in ways of keeping our brains young, by moving, by eating right, by sleeping enough, by being mindful, by being involved with others, by being altruistic even, by being involved socially. And so, and I think what we know about exercise, if you do a social exercise, something like Zumba, or something like yoga where you do it together, or Tai Chi, you learn how to do it, or playing a musical instrument where you're moving your fingers and moving your brain at the same time. This makes your brain work hardest. And the brain loves to work hard, and it does the best for you. So with that, I will stop and answer questions if you should have any. Thank you.